Welcome to Notes 11.56. Thus far in this unit, we've been talking about the perimeter and area of polygons. And today we're going to start talking about the perimeter and area of circles. And when we talk about the perimeter of a circle, it's known as the circumference. Okay, so we're going to begin by talking about arcs. And arcs are simply part of the circumference of a circle. And you can either talk about arcs in terms of their measure, in which case you're talking about the degrees of the arc, or you can talk about it in terms of the length, in which case you're talking about the distance of the arc. And in a circle, the measure of the arc equals the central angle. So measure equals central angle. All right, and the central angle obviously is one that comes from the center of the circle. So let's look at our example here. We've got circle C. Circles are named by their center. And we need to find the measure of each arc. Well, first let's find the measure of each angle that's going on here. This one's obviously 130. This one is 90. This is a diameter because it runs through the center of the circle, which means that if this is 90, the diameter cuts the circle into two congruent parts, which means it cuts it into two 180-degree arcs. So this one is also 90. And then if this is 180, then this one is 50. Okay, so the measure of the angle equals the measure of the intercepted arc. So 90 degrees here, AE is 90 degrees. ED is the distance from E to D, the shortest distance from E to D, and it is equal to 50 degrees because that is its central angle. All right, then we start talking about DBA. Well, DBA is this arc that begins at D, goes through B, and ends at A. And it's simply the sum of these two angles right here. So it's 130 and 90, which is 220 degrees. If I go to AED, it's the arc that starts at A, goes through E, ends at D. So it's 90 plus 50, which gets me 140. ABD is the exact same arc as DBA, just in the other direction. So it is also 220 degrees. And then arc BD is simply 130 degrees. All right, so I would like you to find the measures down here in circle O. Let's get a head start. Let's talk about what all these angles are. Okay, EOC here is a diameter, which means that this is 180 degrees. So I take 180 and I subtract 55 from it, and I get 125 degrees. Okay. These two right here are vertical angles, which means that this is also 55 degrees. And then this angle and this angle are vertical angles. And furthermore, these two are congruent. So these are each half of 125. So each of these is 62.5. All right, so now we found all of the central angles. Go ahead and answer all of these, please. Come back when you have an answer. Hit pause now. All right, these are what you should have gotten. Go ahead and hit pause if you want to check your answers, but I am moving on. All right, the circumference of a circle is either 2 pi r, or we can also call it pi d. These are the two formulas for circumference of a circle. Let's use them. The dimensions of the skateboard wheel are shown at the right in millimeters. To the nearest meter, how far does the wheel travel when it makes 35 revolutions? All right, so a revolution is once around, so we're talking circumference. And here, let's go ahead and let's find the diameter. So the diameter is all the way across, so it's 20 plus 15 is 35. So we've got 55 millimeters is my diameter. All right, so my circumference is going to be pi times that, so pi times 55. And then furthermore, it's going to go around 35 times. So it's actually 35 of my circumference. And we're going to need to go ahead and multiply this all out. It asks us to the nearest meter. Okay, so that means approximate. It's asking us to round to the nearest meter. So it's asking us for the approximate. So we are not going to leave pi in our answer. We're going to go ahead and multiply it through by pi. Now, we all know that pi is 3.14. But unless we are specifically told to use 3.14, I want you to go ahead and use the pi button on your calculator because it is more accurate. So go ahead and multiply this all together right now. Come back when you have an answer. Hit pause. Okay, so you should have gotten about 48 millimeters. But this asks for our answer to be in the nearest meter. There are 1,000 millimeters in a meter, so we are going to move this 3 decimal places to the left. So we are talking about approximately 6 meters. And that's our answer. Moving on. So earlier we measured our arcs in degrees, and we said that was the arc measure. And then we also had an arc length, which was a distance. And the way we find an arc length is that it is part of the circumference. Okay, so I like to think about it as setting up a proportion. And we are looking for the part of the circumference. So on the bottom is going to be the whole circumference, because we like proportions that are part over whole. And we're going to set that equal to the part of the degrees, which is usually the central angle, although sometimes they do actually give us the arc. And on the bottom is the whole degrees, which is always 360. So part over whole equals part over whole, and that's all we're talking about here in this formula that looks kind of complicated. And this is simply this formula solved for the arc length, but I always like to just set the proportion and go from there. So let's use that. We need to find the arc length of AB. So we need to find the parts. All right, so I'm going to set up my easier part over whole first. I'm given the central angle. It's 88 degrees over my whole number of degrees, which is 360. And then the thing that I'm looking for is the arc length, which is my part. So that gets my variable. And it's going to be over my whole. My whole, if this is part of the way around the circle, I'm looking for the whole way around the circle, which is circumference. And circumference is 2 pi r. And since I know radius, I can plug that in. So 2 times pi times the radius. And then I simply need to solve this. Now, unless you are told otherwise, you are going to leave it in exact form. Exact form means don't round, which means keep pi in your answer. Okay? So let's go ahead and do that. So 2 times 2 is 4. So we're actually going to take and we're going to cross multiply. All right, so I get 360x equals 88 times 4 pi, which means that we're going to divide by 360. So x, my arc length, is going to equal, and I'm just going to, in my calculator, take 88, multiply it by 4, and divide by 360, and then I'm just going to tack pi on the end. Now you remember from before that when we did exact, it also meant fraction, right? Fraction, simplest radical, or pi. These are all the things that exact means. So when we actually multiply, we wind up with 44 over 45 pi, and this would be in meters for our unit. All right, let's look at that in the calculator. Okay, so for those of us who are still a little, shaky on our calculator, we would have taken 88 times 4 and divided by 360, and we would have gotten this decimal, right? But we need to convert that to a fraction, so we would hit math, enter, enter. And that gets us our fraction of 44 over 45. And then we just tack pi on the end, okay? Your math, enter, enter is your friend when converting fractions to simplest form or converting decimals back into fractions. All right, moving on to the next question. All right, in this one, we are looking for the angle measure. This little m right here tells me that the thing I'm looking for is the angle measure. So I know that my answer is going to be in degrees. And that means that that is the part that I'm looking for. So I am looking for the part of degrees over the whole number of degrees. And what I know is I know that my arc length right here, RS, is 38. And then they were nice enough to tell me, because this is a little confusing, that my radius is 12.3. Right, so that means that my circumference is 2 times pi times 12.3. Now, degrees do not have pi in the answer. Okay, so no pi Degrees are always to the nearest whole degree. Nearest whole. Okay, so we go ahead and we cross multiply and we solve, and we get what, 24.6, so 24.6 times pi times x equals 38 times 360. And so to solve for x, we take 38 times 360 and we divide by 24.6 pi. All right, let's put this in our calculator because this gets a little bit tricky. So we take our calculator, and if you want to do it all in one step, you're going to take 38 times 360, no biggie yet, and then you're going to divide by. So here's the key. If you just type in divided by 24.6 times pi, you are going to divide by 24.6, but then you're going to take that answer and you're going to multiply it by pi. So this, you need to consider whatever happens in the denominator of your fraction to be inside parentheses. So we're going to open some parentheses, and we're going to do 24.6 times pi. And we're going to use the pi button in our calculator. All right, and we hit enter. And we get 177 degrees, right? Which is why it almost looked like it was a diameter, because it was very close to being 180 degrees, but not quite there. So let me write that down, 177 degrees. Let me just show you what would have happened if we had done it wrong. So if we had typed in 38 times 360 divided by 24.6 times pi. So notice this time I did not use the parentheses. I would have gotten 1,747, which I would have known, because I'm smart like that there's no way that part of a circle could be way bigger than the whole circle, which is 360. So I would have understood that I made a mistake, but I might not have known exactly where my mistake was. So you can see the difference that it's made to not have my parentheses. So you got to always remember, if you want to do it in one big type into your calculator, that you've got to put those parentheses in there. All right, let's move on. Let's do a word problem. We've got a conveyor belt for luggage at an airport is shown at the right. The outer part of the belt forms a 180-degree arc at each end. For each arc, the radius is 8 feet. Approximate, so there's that word approximate the distance around the belt for a coin on the outer portion. I don't know why you're putting a coin on the outer portion of the belt, but you are. You're bored. You're waiting for your uncle to show up, and he's always late. So you're standing at the luggage carousel, so you stick a penny on, and it goes all the way around the luggage carousel. Okay, this 4 doesn't matter. Doesn't appear in my problem at all, so we're going to ignore it. What we do know is that the outer part of each belt forms a 180-degree arc at each end. So basically what's happening is I've got a half circle right there and a half circle right there. And together, that gives me a whole circle. Always like when that happens. So, and then the straight line distance is 20. So my penny goes 20 this way, then goes halfway around a circle, and then it goes 20 this way, and then it goes the other halfway around the circle. So basically what I have going on is I have 40 feet of straightaway plus a circle, which is, since we're talking about the distance around the circle, circumference. So my radius is 8, so it's 2 times pi times 8 feet. So if it were asking me for the exact answer, then I would say that it is 40 feet plus 2 times 8 is 16 plus 16 pi feet. And since this one has pi and this one does not have pi, those are not like terms, so I could not combine them. However, it's not asking me for the exact, it's asking me for the approximate. So I'm going to go ahead and multiply 16 times pi in my calculator and add it to 40, and I get, to the nearest foot, I get about 90 feet, and that is my answer. So here we're asked to find the circumference of circle F, which is interesting. So this is actually degrees, right? 290. So we know our part of our degrees out of our whole degrees. And we know the partial distance around the circle, 46.75. And what we are looking for is the whole distance around the circle, also known as the circumference. And so we just simply need to cross multiply and solve this. And since our arc length is not in pi, our circumference is not going to be in terms of pi. Had our arc length been in terms of pi, we would definitely have done our circumference in terms of pi, because circumference is one of those things that we do measure in terms of pi. So I would like you to please cross multiply and solve for the circumference. Come back when you have an answer. Hit pause now. All right, you should have gotten your circumference was about 58.03 feet. My general rule of thumb is if this has 2 decimal places, then I'm going to give my answer to 2 decimal places. But you don't really need to worry about it, because on quizzes or tests, we're going to tell you exactly how far to go. All right, let's look at this next one. This next one asks us for the radius of circle J. Okay, so it gives us a central angle of 55 degrees, and it gives us an arc length. So we know that my 1 part over whole is going to be 55 over 360. And then I know my other part, 19.71. Now, you got 2 options here. Either you can do exactly what we did over here and solve for circumference and then work backwards. Or you can just write circumference in terms of pi, 2 pi r. And now we're going to solve for r. So we're going to cross multiply and solve this bad boy. I would like you to do that and come back when you have an answer. So hit pause now. All right, you should have gotten 20.53 centimeters for your radius. If you don't know how that happened, be sure you ask in class. All right, the next section of the notes deals with area. Oops, I lied. There is one more question that deals with circumference, and I would like you to do this one for the notes check. All right, now the rest of the notes deal with area, so I'm going to end part 1 here, and we're going to pick up part 2 by talking about area. See you there.